In this video, I'm going to solve the problem 17th from chapter 16, page 1 from Principles of Physics, 10th edition. Okay. A nylon guitar string has the linear density of 7.2 gram per meter and is under a tension of 180 Newton. So here you have a string which is a nylon string, and that string they used in the guitar here. So that string linear density is given as we already studied in the theory. The linear density mu, which is equal to mass per unit length, they already gave the answer for the linear density of the nylon string as 7.2 gram per meter. So better I can convert in terms of kilogram per meter. So therefore 7.2 multiplied by 10 to the power of minus 3 kilogram per meter. And the tension applied over the string is 180 Newton. And these strings are fixed support. So you have to see the figure. The two edge of the string is fixed, right? So the distance from the fixed supports are given as 90 centimeters. So what's the distance? Which is 90 centimeter. So I have to convert again to meter, which is 90 multiplied by 10 power minus 2 meter, right? The string is oscillating in the standing wave pattern. So while we apply the tension, and once the oscillator oscillates, it will produce the standing waves over the string. By using that, we are going to find the answer for 3 questions. In the first part, we are going to find what is the speed of the wave on the string. In the second one, first question, we are going to find the speed, and in the second question, we are going to find the wavelength lambda, and the third one, we are going to find the frequency. Clear? Okay, let's start one by one. First of all, I'm going to find the speed of the wave on the string. As we already studied, V equal to square root of T over mu. And we have the data for this tension as well as the linear density. So I'm going to apply the value. The tension here we applied is 180 Newton, right? So 180 divided by, what is the linear density value? Which is 7.2 multiplied by 10 power minus 3. So 7.2 multiplied by 10 power minus 3. Let's see what is the answer for the speed of the wave. Therefore V equal to 180 over 7.2 10 power minus 3. Actually the answer is 158.1. 158.1 meter per second. For your calculation, if you just rounded the value, no problem, okay? But I'm going to take as it is. It is 158.1 meter per second, which is the answer for the first question. In the second question, we are going to find what is its wavelength, right? So how to find the wavelength? You have to see the figure here. In the figure, while you oscillate this string, it has 3 loops, right? So for these 3 loops, first of all, you have to identify what should be the wavelength, right? So let's we just calculate properly. So for that, I can draw the diagram one more time. That will be easy for our understanding. Clear? So second question, we are going to find the lambda. So actually here you have a string which is fixed at both ends, and it will have 3 loops, right? Okay, and then the distance between the fixed support is given as D, which is equal to 90 centimeter. In the previous video, I told you how to calculate the wavelength from the loop. So if you have a loop, each loop will have a quarter of wavelength. How many wavelength? Quarter. That means here you have lambda over 4. Here also you have lambda over 4, lambda over 4, lambda over 4, lambda over 4, and so how many lambda over 4 you have in this d? So the total distance is d. In this distance, how many lambda over 4 you have? 6. 1, 2, 3, 4, 5, 6. That means 6 lambda over 4 you have. So now what I'm going to do, I can cancel this. This one is 3 times, this one is 2 times. By that, you can easily find the lambda. Therefore, lambda is equal to 2 multiplied by d over 3, right? So I'm going to use this rule here. Lambda is equal to 2 multiplied by d over 3, and d is already mentioned, 2 multiplied by 90 centimeter, 90 multiplied by 10 to the power of minus 2 over 3. So what's the answer? I'm going to calculate 2 multiplied by 90, 10 power minus 2 over 3. I got the answer as 0.6 meter. What's the answer? 0.6 meter. The unit for the wavelength is meter. So this is the answer for the second part. In the third part, we are going to find what should be the frequency. As we already studied this formula in the theory, speed which is equal to frequency multiplied by lambda. Therefore, the frequency which is equal to speed over lambda. So speed part and the frequency, the lambda part, we already found in part A and part B. So I'm going to take the value of V and lambda from the previous answer. So V, we got 158.1, 158.1, and the lambda in the previous part we got 0.6. So let's see what's the answer for the frequency. So frequency equal to 158.1 over 0.6, which is 263.5. The unit is hertz or 1 over second. So this is the answer for the third part. Clear? That's it. Thank you.